So I just want to start off with like some acknowledgements. So the idea was from Alex and Amita, and yeah, I'm just presenting the protocol today. So the outline is I'm sure it's probably mentioned in the previous talks, but I'll just review the main stablecoin types. I'll go over the Dexy design at a high level, some useful notation, and then the rules for the liquidity pool, the bank, as well as a theoretical worst case scenario for the bank reserves. And then I'll explain how those rules are related to the stability of the protocol. And then just quickly highlight the different implementations on Ergo and some possible further analysis that would be interesting. So the sort of three main types of stablecoins that exist right now are the fiat asset-backed, so like USDC, Tether. The main downside of those is like the trust that they hold actual physical assets. And usually the digital assets you get can be seized or frozen by the issuer, so that's not ideal. Then there's crypto collateralized, so the collateral you put in, just so when you guys maybe like a loan, and usually the collateral can get liquidated, the price depegs, so again, obviously that's not great. And then newer stablecoins like Dexy, Jet and Gluon, they're crypto-backed. So these stablecoins rely on the implementation to be correct, like to implement the algorithm properly. And as we'll see in the case of Dexy, you need like the off-chain code to work properly, because for most users that's how they interact with the protocol. And in the case of Dexy, that's also how the stability is guaranteed, so that's important. So at a high level, the Dexy design consists of an algorithmic central bank and a liquidity pool, specifically a constant product automated market maker, as well as a trusted oracle for the price, which is used by the bank. So users can interact with the bank and the liquidity pool, and there's restrictions on both, depending on the price of the oracle and the price of the liquidity pool, which determine how the users can interact with each. So I'll just go over it. So the liquidity pool holds the base coin pair of the base coin and the Dexy stablecoin. And since it's a constant product automated market maker, the product remains invariant before and after a trade. So a user can deposit a pair of base coins and Dexy and then obtain the LP tokens. And then you can also withdraw LP tokens to ideally get your liquidity back plus fees obtained from the people trading. And in the case of Dexy, there's a fee that's charged to prevent like the disincentivize people always like wanting to redeem their LP tokens too frequently. The algorithmic central bank, so as a user you would deposit your base coins and then mint corresponding amount of Dexy stablecoins. The price provided by the bank always equals the oracle price. So like for example, in like Gluon or Jet, it's not like over collateralized. And there's a fee that's charged just to make sure that the reserves can increase faster, which will be useful for the stability properties the bank can do, like the interventions. Yeah, so under certain conditions, the banks can intervene into the liquidity pool to control the price, and we'll go over that. So some useful notation before I explain the different rules. So what's more important is the period or delay for a particular bank rule. And in this explanation, the oracle price is defined as like stable coins, the units are stable coins over base coins, not the inverse. S is like the price when the bank should intervene in case the oracle price crashes suddenly. So E which is the amount of base coins in the liquidity pool, U, the Dexy stablecoins, and R is important. It's the ratio between the Oracle price and the liquidity pool price. Yeah, so the other ones aren't as important as much, but so the first rule I'll go over is the LP, the liquidity pool rule. So if the Oracle price is lower than the pool price by some percentage, then you'll be prevented from withdrawing, like redeeming your LP tokens to get your liquidity back. And the rule applies right away once the threshold is met, so there's no like delay. And so the intuition behind why there's this rule is, so as I mentioned before, the bank can intervene into the liquidity pool to inject funds. So ideally, you would want, like whenever the bank intervenes into the liquidity pool, you would want people to, like the LPs to be prevented from interacting with the bank at the same time. So just making these preventing withdrawals at the same time as an intervention can happen is like kind of the ideal case. But swaps are still allowed between the base coins and stable coins. So as in Polar, the consequence of withdrawals from LPs are chosen to prevent further price defect. For the bank, so minting is allowed in two cases. So the first case is for arbitrage minting. So the Oracle price it must be greater than the pool price by some amount, or some percentage. And unlike, so in this case there's a time delay. So the Oracle price must be greater than the pool price for this amount of time, at least. And if so, then this rule applies. And when you're minting here, the bank will charge a fee to accumulate reserves faster. And the price at which, like when this rule takes effect, determines the max amount of stablecoins that the bank will mint, and the corresponding amount of base coins it will accept in its reserves. So, as a consequence, purchasing Dexy for the bank at a discount, and you can sell an LP as at a premium. So this increases the supply in the liquidity pool. In the following slides and the previous slides, I expressed R as like 1 plus some epsilon, just so the epsilon represents you can think of it as like the percentage, above or below 1, basically. Because ideally you would want the ratio to be 1, the price is the same in both the liquidity pool and the bank. So in the second case, you can mint, it's called free mint. So this is like the system.